right, the cold caffeinated beverage is cracked open, and it's time for another weekly live stream. This is where you guys get to watch me code bugs into Mythruna and then hunt them down and fix them before the end. Usually, hopefully. Tonight we're going to be working on making our Gaefen a little smarter. I think we'll get to the AI to the point where I'm ready to stop for now, and I'll talk about that. Again, just going to thank my patrons again. You guys mean a lot. If I could pronounce everybody's names, I would read them off. But anyway, let's go ahead and get started. Trying to decide whether we jump right back into where we were or talk about the things I accomplished this week. But let's just do a quick overview of the things I accomplished this week. So, as many of you are aware, if you watched the live stream on Monday, excuse me, I was working on fractals, and it's been a good vacation from that perspective because, as it turns out, that required a ton of dedicated time, just hours and hours of tweaking this and tweaking that, and I finally converted everything over from the stack of samplers into like a custom fractal implementation that keeps it all together and is more optimized. It doesn't bother to calculate the cellular data unless it needs to, and so on and so forth. So it's about 3 times faster than it used to be. We'll see. The map is still catching up. Like, these areas look a little weird because I tweaked the map settings. It automatically generates this, and it needs some tweaking to work with the real fractal because it was set up to work with the default. And so some of these things look really nice, but these kind of coastlines that look like these would be really steep, coastlines, but these are actually shallows, and it's just stretched so far that it looks black like that. So I need to work these things out, and where all these green areas come from, I don't know, because we're kind of in the middle of a desert right now. But so far so good. So you can see the plateaus in the background there. Let's by the way, somebody asked if this, I think they were asking if, I misunderstood the question before, but somebody asked before if this time debug thing is available in the regular game. If you're playing single player, it is. If you hit T, it pops this open and you can run the days for it. It's a little weird sometimes, but for the most part, it works. So we can see the sunrise and fly super fast. You can see this is the desert that I was talking about, and we got some plateaus off there in the distance. That'd be pretty cool to explore. I think there's a city that likes to generate there when the cities are working. Anyway, I'm not going to run into this too much, but you can see plateaus off in the distance, and they all look much better than they did before. The walls aren't as steep. Things I don't like, well, for one thing, because the deserts and stuff are so flat, the stupid default building generation that I have is way too dumb. I mean, it just basically plops buildings all over the place, and even in the middle of the desert. So when we get real towns and cities, this won't look so dumb. I may at least tweak the algorithm to not generate so many in the desert. But this is the other thing I want to fix, is that the temperature climate fractal with these smooth terrains, and I'm hoping that when I fix the terrain to not be so smooth anymore, because that's the other thing, I have to add a ridge fractal and step this fractal up one more level of detail and so on. But the division between arid desert and dirt is too stark, and I'm thinking if the bumping of the terrain doesn't fix that, then I'll have to tweak the temperature and climate fractals so that they're a little more detailed as well. Anyway, so it's coming along. I'm trying to get this done this weekend so I can put out another release. Anyway, so that's what that was. In the meantime, I was also working on dungeon layouts, which some of you may have seen some of the tweets about that. And I'm running the wrong tool, so let's run the correct tool. Yeah, I was running the map tool again. I spent a lot of time in that map tool over the last few days. All right. So this is blockhead and I made it configurable so that you can make a really wide build platform, and that way I could play with what I did first was I made like this dungeon test map, which was just sort of copied directly from this one of these online D&D maps. So I tried to do my best to copy it, at least in spirit, and then add some embellishments for ceilings and things. And the way this works is that I wrote a script that turns these wattle and daub blocks into empty space, and anything else gets transferred directly. And what that lets you do is you run the script in the dungeon generator, and so then it fills the stuff in, and then you can go, let's see, you can go inside and run around and check. This lets me check things like lighting and styles and stuff, like how much light is too little and too much. I want to be able to just barely see into the corners, and we're kind of like that. It's a little easier if I close these to get a feel for what it's going to look like. So then you can run around in the dark and kind of see lanterns are good sources of light. This is maybe a little too dark, but the other thing is eventually the player will have a torch that they carry around, which will shed some light. And so I won't really be able to place lighting accurately until I get to that. But this allowed me to check. I don't like this lighting. It's too bright. The flames are really good. They don't cast very far, but I do like them. I have a pet peeve about dungeons that have flames that there would be nobody to tend, but they do make good lighting sources. And this room is like the main feature room. Like in a real dungeon, this would be the last room where the boss is or whatever. That's why I gave it like a cooler ceiling to test things out. Anyway, that was this part. But what I was really, that was sort of the step one to playing with random dungeon layouts, which I wrote another script to do that. So if I execute that script, it makes these random dungeon layouts. And so this is kind of cool. So it generates some like main feature rooms, and then these gray paths are the ones that fully connect all of the rooms together, and then it sort of generates some random alternate paths. And it makes some pretty good layouts with just tweaking the this is the thing is with these scripts I can go and edit them live. And where is the script? There it is. So I can edit them live and go in here. So let's say what's seed 42 look like, and run it again. Well, seed 42 breaks. That's not good. Let's go back to some seeds I know work. 0. Oh, good. Now I know a seed to check to see why it doesn't work. So anyway, it's kind of cool. The next step would be obviously to try to use that other script so that I can run around in this. But I really want to get this implemented and integrated into Mythruna, at least in a minimal way, so I can generate a couple, maybe one random dungeon per kilometer tile, just so that we have some things to explore. So that's where we are with all that stuff. Tonight we'll be working on AI. And where we left last time was that our Gaefen will randomly switch between, well, not randomly, every so often we have it configured to switch between 5 seconds of just standing still, 15 seconds of random wander, and another 5 seconds of arrive, where they try to go back to the spot where they were spawned. One of the important things about an artificial intelligence, and one of the next sort of what do I call them? The base principles. What are the first principles is perception. So how does one of these brains or the agents query the world to find other things? And since one of the next steering primitives I wanted to work on was pursue, one logical thing would be for it to query for any other Gaefen around it and just steer towards, follow one of those Gaefen around using a pursue steering primitive. But to do that, this starts to get this little hack we put in to just switch around, every few seconds or whatever to do things is starting to become a little unwieldy. So I thought I'd go ahead and add one more layer of switchable behaviors that we can use, and then we can implement, you know, an actual idle behavior, an actual wander behavior, and some main bait. So kind of like a behavior tree in the sense that there would be like a default behavior that we could use to switch things around. So without further ado, let's get started on that. So we'll create a behavior .java. This will be an interface. Right now, this is locked up in Mythruna until I formalize it and put it in a general AI package. Don't need logging in an interface. We know when we set up behavior, we'll want to start it, and maybe there'll be some parameters we'll pass there, and we'll still want an update similar to what we get over here. I'm really wishing I had used step time. Does the agent driver even get step time? No, it doesn't get step time. That's why it didn't use step time. Alright, so we'll continue this bad practice that we already started. We'll continue to use that same parameter. The thing is, if we had used step time, we would get all of this in one parameter and a bunch of other methods that we could use. And let's say we need a stop. So as we swap behaviors out, we'll start the behavior, we'll swap the behavior, or stop the behavior. And so, but while the behavior is active, it will have update called. All right. And so at minimum, let's say we will want a default behavior. Or that's not really the accurate word I want to go through. That's the, yeah, we'll call it a default behavior, but it's the kind of always on behavior. Current behaviors. So there's two ways to handle it right. You could have a default behavior that's only run when there is no current behavior, but it's also kind of cool potentially to have it like a default behavior that's always hit and can have all your perception stuff built into it. We'll kind of play it by ear. I don't really need to at the moment because what we're going to be writing is really simple. So we won't need this switching because we'll let a behavior do that. Yeah, because we can now, this is kind of like a behavior tree. It's just informal. So let's say there will always be a default behavior, and as my pattern typically goes, we'll have a behaviors class that has the factories, so we can have some standard behaviors that just come out of the box. Assume AI. We'll get to some cool stuff here in a second. Hold on. Behavior idle. So will we want to have behaviors? The thing is, I'm curious what I need to pass here. The brain or the agent? See, the brain has access to the agent. So we'll pass the brain. Every behavior will have a reference to the brain, which means for now, because we don't have an actual agent interface, well, we do, but I'm not using it. Agent driver, get agent. So this is the agent that belongs to this brain. I'm thinking ahead in like 4 different directions, so apologize. If anybody is watching and has questions, please feel free to ask. And we'll presume that there's always a brain. But, you know, we don't require that. That's fine. So let's static class idle. Turn new idle brain. Private brain. This will also be a nice cut and paste for the other brain. the other behaviors we have to create. This dot brain equals brain implements behavior. Yeah, I'm already seeing some things that I'm making decisions about as we go. The whole default behavior versus current behavior. I think I'm just going to have a current behavior. I guess default would be what you... Yeah, well, we'll work it out. Okay. The reason I'm thinking this is because at every update, I don't want to reset the steering primitive. I would like to just do it when this idle thing takes effect. And so what did we do before? We did these things, and I'm just going to... Just for a second. So cut, paste, brain, get agent, set default action, idle. Okay. Brain, get agent, set steering. Again, these interfaces are all in flux, and this is where we just do the constant. It's just about to ask if this is building other mobs. I mean, right now we're just working on the Gaefen, but absolutely this is the idea, is that we'll start building this out into other mobs. So we'll set the steering behavior to the constant, which we actually could have built into the... Yeah, okay. Probably we can set up a constant later. Okay, so when it starts, you do this, we don't do anything on update. And this is where we would add the kinds of perceptions that would take us out of idle, which we may work on later. And for stopping, we don't care what happens. The other behavior, any other behavior will pick that up. So, in fact, we can do let's just get ones that we can switch out. So we'll make another wander one. This is where it gets weird, because we don't... Wandering is not a behavior. In fact, I don't like this interface at all. I don't like this at all. So what we want is it's not idle. What's the word I want? It's the one where he's just doing that. Idle is pretty good. It's just overloaded. But we want to not only define... It's not really idle. It's just kind of a constant. Yeah. So we want default action and steering primitive. Okay, so with these, but yeah, to answer your question, we're working up to getting these to be reusable for other AI, and that's kind of like, by the time I get these interfaces sort of worked out, I'll start thinking about how I would add scripting, a scripting API to develop AIs, and then so we'll have the Gaefen, and maybe I'd like to have some simple NPCs walking around. Since we already have the model for Fade, we could have different versions of Fade walking around, but I really want to make a dog to chase the chickens around, because that's a good set of interactions that tend to lead to emergent behavior and stuff, and it gives the chickens a lot of smarts for not much work. Like, you can build some simple behaviors that say, once we have events set up, say, if the chicken sees something enter its field of perception that's moving really fast, then it flees that particular thing because it gets freaked out. And whether it's a chicken or not, right? If it sees something running towards it, it just freaks out, or moving really fast towards it, like a ball or anything you throw at it, then it moves away really fast. Default action and steering. Okay, so when we start, we do that. For update, we don't do anything. The brain is going to be doing all that work for us. I mean, not the brain, but the... Okay. And so now for our default behavior, we can do behaviors. Yeah, we'll do this. Behaviors. What I call it constant. This, idle, this. And so I think I had finished my thought before. But anyway, yeah, so then you have a dog. You build the dog the behavior that when he sees something new, a creature in his perception, then he runs up to it, right? So if you walk into his perception, he'll run up to you and bark at you or whatever, because that's one of the things that dogs do. And if and so then with those two actions together, if the dog sees a chicken, he'll go running up to it. But the chickens will get used to the dog, and the dog can wander around. But then if the dog ever wanders away from the chickens and comes and he sees them again, he'll come running back up, and then they bark, 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 and they run away. Or the Gaefen, right? Okay, so we've got a default. We can get rid of all this stuff. We don't need these anymore for the time being. I'm just going to comment this stuff out. What we want to do, though, is kind of have this shuffle that goes on. Current behavior equals null. Set current behavior default behavior. Cannot type. Okay. And then current behavior update frame time. This is going to bug me. So now we say public void set current behavior. When you code a lot of APIs, after a while you get like a built-in sort of habit on life cycle, and you automatically have like these methods where you think of this. So if this behavior equals the behavior, or this current behavior, these kind of patterns, if equals the current behavior, even the behavior past, we don't do anything. We're already there. So that's a no op. If there is a current behavior, we know we're switching it, so this is one we have to stop. Then we set the current one equal to the new one, and I'm gonna, from experience, if I don't name these the same, this will get me in trouble later. So that, and then now so we want to say equals null default behavior or current behavior. That's still in my nope. Okay, and then so we've got a new behavior. Always have a new behavior, so we'll start. So now we have swappable behaviors. This guy's doing its thing. If it doesn't have a current behavior, it'll set the default behavior. So already, if we place a Gaefen, he should do his idle animation. And that's it. So let's check to make sure we haven't broken anything. Probably there's compiler errors and things. Yep. I rename the constructor to match the class. Dope. Where's the actual error? Okay. Set current behavior. Oh. You guys probably saw this and were like, you didn't name it right, you didn't name it right, and I didn't even finish it. Alright. the neat thing about that dungeon algorithm is that it will allow me to have like special features. So I can randomly generate rooms of, just boring rooms of a particular size and fill them with stuff. Or I can use a similar algorithm that generates, building floors to make, rooms out of parts. Or I can have like specific room, like there's a throne room, that's specifically built, kind of like our, the skull and different things out on the world. And then populate the level with those, and then it'll connect everything up for me as part of the algorithm. Randomly place those around or specifically replace them around. The idea is as you build multiple levels deep, specific levels will need to have some features already pre-built because, they need to line up the stairs with the lower level and the upper level and stuff. All right, so let's go back over to our little thing. Eventually I got to make an object to represent home. Maybe I'll make a little trough or something. Alright, so let's place a Gaefen, and he should just stand there at idle. And he does. Okay. Alright. So instead of having him idle all the time, we will make his default behavior a wander. And so we'll steal this wander behavior. This one. Oh yeah, we gotta scale the speed. Forgot about that. Okay, and we do want his default action to be idle. So if he gets blocked, he just stays there at idle. And the next thing we're going to want is start thinking about perception. And this is where, this is where the constant behavior doesn't work so well anymore. We would want to develop a specific behavior. Or let's think what we want to start with. We want a behavior. So I'm going to leave these here for now. Let's sort of set up a behavior here. Call it Gaefen. And we'll go ahead and later we'll create an abstract behavior, so I don't need to implement these methods every time. But so this is our main brain for the Gaefen. This would be the master behavior in a behavior tree that has all the other behaviors underneath it. And when we start, we don't really care to do anything. When we update, we can go back and sort of do our previous. So we could actually, I think that probably we want at least start to have the same. It's quite common that when you start, you would want to start tracking time. So we need that here as well. Yeah. I think I screwed something up over here. Nope, that's good. Brain. That's good. Okay, so yeah, so we can do our sort of this thing, right? So we can set time equals 0, that's fine. Next time equals, what do we have it? So we'll just alternate every 10 seconds between one and the other. Okay. And so then an update, we do the kind of thing we were doing down here. So time plus equals step. And if time, so we'll set this step up again. Set time equals 0, right? We'll just keep track of all time. Yeah. Yeah, that's what I did before. So time equals time plus 10, which is what we did before. And we can go ahead and change our behaviors. So, what do I want to say here? So these would be things you'd script ahead of time. So let's say every 10 seconds we switch. And this one's constant. Really, we're not doing anything different here, but we're going to have the opportunity to. So we'll idle, then eat. Idle, eat, idle, eat. Yeah. So we'll just swap these back and forth every thing. So if the current behavior equals idle, set current behavior eat. Except for we are the current behavior. We will then be taken over. Yeah. That's the issue, right? You almost want perception events. So we'll treat default behavior as the thing that runs all the time, and current behavior is sort of the thing that gets added on top of that. So this will be our default behavior. Like before I forget, let's set default behavior equal to Gaefen. The problem is there's a whole bunch of infrastructure that we haven't built yet, so things get muddy here. We see we're swapping in and out the eat. And I could have done one of these as set null so it just defaults back, but we're going to treat default behavior a little differently. In fact, let's change this to global behavior. And no, we'll still have a default behavior maybe. So we'll still have a default. Yeah, that's what this is. So the default is the one we'll switch to when nothing else is around. And the global behavior is the one that will always be there. That's the main brain behavior that will switch out, you know, the other different behaviors. And so we technically could have done, let's see, if this is equal to idle and eat, then go to idle, but we could have said null here and it will default back to the regular idle behavior. And let's test that. Okay, so we already have this. So set the current behavior to null, which will go back to the default behavior. The global behavior equals the Gaefen. Default behavior equals the constant thing that, yep. Okay. And then down here, if global behavior is not equal to null, global behavior update frame time step. So that gives us a chance to catch events and do other things. Right now we're just swapping in and out. So we don't really use our start. So we just so we'll just initialize those because, you know, whatever. We won't start tracking time until we actually get an update. And so global behavior, we're just using that for the update. But there may be a different interface for this in the future because we don't swap them out. So this should work, right? every 10 seconds it should switch between those two behaviors. Let's see if I screwed something up. So we haven't even gotten to perception yet. Oh, yeah. Okay. I'm going to undo what I did because I changed the way I'm doing things, and when we call start, we actually don't know what the current time frame time is. If we had an animation, if we had an actual AI system, it would know. But for now, let's leave that out. So start becomes easy. Okay, let me see if I forgot one. Okay, I did idle. We don't have an idle anymore. So current behavior equals eat. Set null, otherwise set eat. Yep, okay. Should work. Oh, I forgot to mention, one of the other things I added was when you're creating a new world now, you can select from a variety of different fractals. Different world fractals. So there's like a sine wave fractal. This is the, I think I called it simple. So let's see what he does. He's eating. Is he ever going to stop eating? Yep. Now he's going to wander for 10 seconds. There's two of them. He's going to wander for 10 seconds. And then he'll eat. There they go. Alright. So now we need to give them a home that they would return to. We could implement the pursue steering behavior, which we could have them flip to. So I'm trying to think what next thing I want to do. And how you would kind of do that is you decide, well, that's what we're here for, right? So to make a home, I would need to really quickly create an object to place down to be home. And I don't want to do that right now. So instead, we will say, let's see, instead of doing time like this, let's do it like we might normally do it in a real thing. So let's say instead of time, we keep track of hunger, right? The hungrier he is, like hunger is essentially time, right? As he's moving around, he gets hungrier. If hunger is greater than 10, then he needs to eat. Okay. Now, normally then we would have to have some concept of when a behavior is done. And so we want to think about that too, right? Because when we arrive at a location, we're done. We don't need to keep doing it anymore. So we could, in fact, have update return true or false or some other status. Or we could ask for the status. Right now I'm going to go the simple option. So behaviors, this will always return crap. Always return true. Keep going, basically. But in the brain, we want to say, yeah. Okay, so down here, if not current behavior update, set current behavior null. So the that behavior will just keep running until it returns false, which allows us to do things like we only want to eat for a little bit. Perhaps then we can have a different sort of let me go ahead and make an abstract behavior because I'm going to get tired of writing these all the time. But Paul, if you're going to implement all the methods, why do you make it abstract? Because it's an indicator that you should not instantiate this directly, because it provides no behaviors on its own. Probably everything will want a brain, but so you get used to sort of typing up these patterns over and over again. At one time I configured my editor to have macros. They're probably still around. I just don't remember how to trigger them to build a lot of this boilerplate for me, but I just got used to just typing them. So let's make this abstract because we don't know. Oops. We don't know what we don't know. We don't know when we're done, and we're going to make the subclass decide. Okay, so we have an abstract behavior, which means that all these guys, this guy could extend abstract behavior, override start. He has to override update, but he does not have to override that one. But what this lets us do is start building some standard behaviors. Like eat's not enough here. We want to make our own behavior. This. So here we'd have start, set the things we want to set. But he's only going to eat for a certain amount of time. Eating. How long is he going to eat for? Let's say it only takes him 2 seconds to fill his belly. And so when we start, we set well, we have access to agent right here. Default animation. So ideally, you know, we would have some base classes that would do these kinds of things for us. So we set him, what do I call it? Set steering. Okay, so now we have a new eat update. Will only run until we run out of time. Update long frame time double step eating minus equals step return eating greater than 0. So as long as there's still stuff, you know, as long as he's eating, and maybe this eating value was could be based on how much food there was to eat or how hungry he was or so on. But now we start to build in real behavior. So instead of, we don't need this to swap us back anymore because the current behavior will swap back automatically. Right, so we're starting to build in like a behavior, right? He gets hungry. When he's hungrier than a certain amount, you know, he sets the behavior. This way we could do some more complicated logic where he could decide to do things based on multiple inputs, whether he's more scared than he is hungry, so on and so forth. But right now, so if he's hungry, he sets the eat behavior. The eat behavior needs to reset eating to 2 when it starts instead of on constructor. And so he'll eat for 2 seconds basically, and then return that he's done, which will make the current behavior switch back to the default behavior, which is us, or it's just the idle behavior. And so he won't wander anymore. Yeah. That's the thing, right? That means when we start, we want to set the default behavior to what we had previously talked about was idle. Or not? Yes. Oh, default is wandering. Okay, cool. We're good. So by default, chickens don't just stand around, they wander around. Okay. So this should be roughly the same behavior we had before, if I've implemented everything correctly. We've got a long way. Extends. We've got like 15 minutes left to do perception, but we had to give a place to hook perception in. Alright, too many things. Set default animation. Cannot find symbol. Default action there. Brain. Set default action. So I was just typing too fast. Update long double. It does though. Or did I spell it wrong? Update long double. Did I not save? Okay, I gotta get rid of those warnings sometimes because they're annoying. Oh, new Gaefen behavior. Should be abstract behavior. Nope, we're good. Actually, we just need to make just a match. Okay, we're getting closer. Missing return statement. Always run the default or the global behavior. Missing return statement. Oh. So this one, super brain. And we actually can simplify this a little bit. Yeah, I apologize, there was more infrastructure to work on before we got to perception. I knew I wanted swappable behaviors, but I didn't really know exactly how I wanted them to flesh out. I think I already have some of the query infrastructure working. For asking for objects. At some point I'm going to have to make it so that these Gaefen don't automatically despawn. Okay, so you should eat for... Uh-oh. They're constantly rechanging their... Yeah, he's not even getting to finish his current... Oh. So he will get hungry, and now he'll eat and he won't stop eating. The reason he won't stop eating is because we never reset the hunger. And also I think the hunger animation may last longer than 2 seconds. So quickly, this isn't how you would do it. Normally you'd have, so the brain itself needs some properties. So for example, the this whole idea of the hunger is actually a, sort of a global thing that we would set on the brain as a property. So we wouldn't keep it here, and we wouldn't have to eat for a particular time, right? Like as he eats, we could just be setting hunger minus equals step times, what did we want? So we wanted it to be for 2 seconds. It takes him 10 seconds to get hungry. So we want that to be refreshed back up to 10 in 2 seconds. So what's that? Why can't I math today? In 2 seconds we want this to be 10, so we're going to multiply by 5. And so if hunger greater than 10, return hunger greater than 10. Or hunger less than 10. So we'll keep eating until hunger is above 10. But that way if we get swapped out, you know, we can, so we're both operating on this hunger variable. That means it gets reset as we're eating. And so now they should toggle. I got rid of all the locals, yep. And really those would be sort of generic properties so that any, you could have hit points, you know, fatigue, any number of things that wouldn't be hard-coded on brain. We'd have just generic properties that the behaviors could operate on. Or even if in some implementations, you know, components on the entity, if you wanted to expose that as game state. And probably we do. All right, so he should eat for 2 seconds. And he's not. He's continuing to eat and eat and eat and eat and eat. Why? Will he walk at all? Yeah, because he'll walk for 10 seconds and then he still gets stuck eating. Did I put a plus instead of a minus, or a minus instead of a plus somewhere? Okay, so he'll eat forever. 1001, 1002, 1003. Okay, so there's a bug in my logic. Hunger plus equals. Yeah, that would be it. Okay, so I'm just going to assume that works because we really want to get moving on something else. I'm going to keep track of what the arrive steering behavior looked like, but I'm going to get rid of all this other stuff. Cleaning up as we go, so to speak. Okay. Now we're set up to say, okay, so if we update, we can also then decide we're lonely, right? As arbitrary. Lonely equals 0. Oh wait, hunger equals 0. That's right, we needed to minus it, right? So we add hunger here. If hunger is greater than 10, then we subtract from hunger. Oh. We need to counteract the... We're constantly depleting hunger even while we're eating. We're constantly adding to our hunger. It's kind of weird to consider hunger a value, right? So if we add, every frame we're going to add whatever the frame time was. We're going to subtract 5 times the frame time. So we effectively add 4. It should still... And if hunger is less than or equal to 0 is when do we want to stop? Update while hunger is greater than 0. Yeah. That's where it was. That's what the problem I had. It was backwards. All right, so anyway, and for now we'll let that interrupt. We'll add a lonely lonely plus equals step. So we get lonely after a while. If lonely is greater than 15, we've been missing our friends. Then we want to query to see if there's any Gaefen around us. And I think we can use the same thing that the probe uses to ask for where to go. probe, query filter, and it creates a ghost shape. So we want to make a similar thing. My mouse wheels drive me nuts. Just copy this for a second. So this will be kind of the general representation of our perception. So it's our perception bubble. And yeah, we'll go ahead and let it implement. So we'll do it exactly like the probe, basically. So we'll have the shape, the radius, offset orientation, all the same things. Position. We don't need contact avoidance. We're not even using it in that other place anyway. Oh yeah, we are. Alright, so calculate steering. Yeah, we don't want to calculate steering here. Alright, so let's ignore that for a second. Perception bubble. I just want to call it something different than probe. So we got all that stuff. We don't need this. We don't need to calculate steering. Reset. So we have an agent, and we need to be able to get the body from the agent, or position. The reason I mean, this would be a lot simpler if I could just center the perception bubble around the Gaefen, but I kind of feel like, you know, if your Gaefen's here, the perception bubble would extend ahead of them and not so much cover behind. So I do want to have a position and offset, but it does lead to some, because I think if we do, let's just steal the, I think we just make a local to world here. Should be fine. Local to world. Yep. I'm gonna leave that vec 3D offset, vec 3D. Yeah. This is target. Save myself some trouble in the future by naming the variable correctly. Target. Return it. I believe it works that way. Okay, so over here, agent, local to world. Yeah, we don't need this. New contact is what we're called with. And so we'll just keep a set of the rigid bodies that we find. Do I have enough? I don't. We're going to have all kinds of problems over here. I don't steal a bunch of this. Actually, just steal it all for a second. And we're almost out of time. Okay, so let's just wrap this up. We don't need any of the SIM stuff. We do need entity systems. We do need... I don't know if we need that. Probably we need those. Don't know if we need game constants. Nope. Okay, so we got a brain, perception bubble, got util, so we can have a set of rigid bodies. But right now we'll just do entity IDs because I'm running out of time. We'll just let it warn us about found. And we can like keep track of the new ones if we wanted to, but we'll just reset it every time. So found clear, and so if see, this is the thing. Yeah, we're gonna want to be able to get the body to foo. Where's abstract control driver? Should be over here next to physics space. Yeah, because this is actually protected, so we'll need to make it public for the moment. I tried to avoid it, but oh, it's final. I can't. Okay, so we'll do it a different way. If agent is us, yeah, so if either of the contacts are us, then we don't care about the contact, right? That we basically would query ourselves, because this bubble will detect anything. And so for now, info contact. All right. And let's see if it'll compile real quick, because I think that I missed something. 149. Oh, yeah, I killed the bottom of the class. I killed my class. Oh, return true. Keep going. We always keep going. All right, so we haven't done any of that stuff yet, but we're getting there. We're getting there. Trust me. Oh yeah, haven't implemented agent is us yet. That's fine. So is us. Plug boy boolean is us. Where's rigid body defined? The ID and block shape body return body equals get body. All right, so now we can tell if it's us. We can just skip it. Alright, so we'll do, the reason is because one side could be a static body, so we will do the detection in here. Actually, this still works, because we're doing reference equality. Alright, okay, so now we can implement actual logic. Alright, so let's see how we used probe. First we create one like this, and so for this guy, private perception bubble, perception equals new perception. Problem with implementing long class names so we want it centered. When you're typing in a live stream, it's painful. So centered, we want it to be about the same height as the other one, but we want it to extend out maybe half of what the perception bubble is. See, how long should a... Let's just make a 2.5, and we'll make it his perception bubble 5 meters. We'll see how that does. All right. Agent driver. Probe. Where does it do the probing? Probe reset. Physics, get physics space. Alright, so we're going to need another interface. Oops. So if we're lonely, we tell our agent to query the contacts, and we use the perception position, perception orientation, perception shape, perception filter. So I'm going to, after this live stream, I'm going to make a standard interface for querying with a probe, quote unquote, because that's going to be painful to retype every time. Okay, so I need to implement that method excuse me, over here, and it would be much easier, you know, if we didn't have to pass a bunch of, so this will work for now. Void query contacts. I don't know if query contacts actually returns anything, so we're just going to do this for for 3D. The orientation, M block shape, query filter. Yep. Where'd it go? There it is. Filter and contact listener. Crap. Stupid mouse wheel. I'm going to steal this. Contact listener. So we could do all the same things except for pause, orientation, shape, filter, listener. Alright, let's see if that'll compile. Ooh. Filter. Oh. And over here, okay. Alright, so that's working. Let's go ahead and run it. Actually, before we do that, let's make sure we catch. The problem is, like, it's not, we don't actually run a behavior, so we're gonna have to reset loneliness to 0, or we'll keep querying every time. Log info, I'm lonely, so we can see that in the logs. Continue. We're getting there. Okay. Continue last world. This will be one of those cases where it'd be nice to have a prototype environment, similar like I have for the dungeon generation. Alright. Oh yeah, see, we just got a bunch of contacts come through. Contact. Yeah, so we'd have to sort through which ones of those are the ones we're interested in. Any of the ones with a null ID, that's weird. Why would a rigid body have a null ID? Oh, that's the shape we sent through. So in fact, in these contexts, we only ever care about... Oh, that's not true. Alright, so let's filter further. We don't care if the... Let's see. Which body do we care about? So let's, if the so that's not what I want to do. Body equals null, right? If contact body 1 ID equals null, not equal to null, and not is us, body equals contact body 1, else contact body 2 dot ID is not equal to null, and that one's not us, then body 6. So, and if body equals null, return. Otherwise, we'll log body. Okay, that will present a fewer logs. And we can start like zeroing in on the chickens. Okay, we've only got one chicken walking around. He's not going to find anything. Like 2 walk around. Uh-oh. Oh, I didn't check to see if it's lonely. So he's lonely. Yeah. Alright. He's lonely, but he can't do anything about it because I screwed up. Contact body 1 is not equal to null, and so similar here. If contact body 2 is not equal to null and body okay, then it's body 2. And we'll go ahead and presume we've if body instance of, you know, this should be abstract body. And then we will just add everything. If we found a body, we'll add it. And we should be able to rigid body. I just feel like we're getting close to having something here. So let's say so let's say of all the things we found, oops, not agent, perception, go through all the things we found, if B instance of rigid body, it will just grab the first one we found. I should have captured both of those when I did that. So B. Okay, break. Okay, so the first one we found, log, found. and then we'll leave the context in for now, but we'll make sure that this log is easily seen. Okay. And I think we'll have enough information in the shape maybe to tell whether it's seeing fade or seeing another, because the chicken will see us too. Kind of a dog with a bone with this, and I apologize for the live stream running really long, but we're really close to having it at least be able to see the other thing and walk to its location, even if the location wouldn't be there anymore when they get there, because we don't have a pursue steering behavior. I don't even know if anybody's watching anymore, so I'm just still working. Okay. So we need another one of these. Alright, we'll watch the we found somebody. He got lonely, he found... So they're doing their eating, wandering thing. It's a high rigid body number, so... Alright. So one of them found null. They're really far apart right now, so they should always find somebody within 5 meters. Yes, stretch out. What I need to do is modify that probe debug state to also show their perception bubbles. Then we'd see like how far they can actually see. At any rate, they're finding somebody. So let's I need to be able to make them so they can talk. Let's leave it here, right? Need to if found file equal to null. So we'd have to create like an arrive behavior to go to, I think it's called position. Yeah, okay. Hi, Lucas. We're almost done. I think we're almost where I'm going to get, because I don't have time to implement a arrive behavior or a pursue behavior. So we're just going to prove that it would walk to a location and be done with it. We implemented a lot of AI infrastructure. And if I feel up to it, maybe I'll do another live... Well, tomorrow's New Year's Eve, right? Yeah, I can't do that. I don't think you guys will want to hang out with me on New Year's Eve. So we'll talk about what I'm trying to wrap up this weekend in a minute. Alright, so he's walking around, and we'll give him a friend to play with. We'll stay far away so that they don't detect us. Yeah, so he needs to walk to... Mark it. Needs to walk to that location. So he found... Does it talk about the shape? No. Probably for the best, the shape. Yeah, rig. So it's a rig. So he found the other Gaefen and he needed to walk to him. So it's essentially working. The other thing that I want to implement before I call AI quote unquote done enough for now is I want to have mobs agents be able to have little pop-up bubbles above their heads, you know, so they can give us feedback. And I don't know if that's going to be a debug feature or a permanent feature, but eventually, you know, NPCs will need to talk, and so having a little talk bubble pop above their are they having difficulty relating to other Gaefen? Yeah, you know, they need counseling and stuff. But that way, you know, even like I can make them have sounds, like I can give it a sound effect, you know, you can go bark, 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 or whatever, but it'd be nice if there was a little pop-up bubble when they made noises. But specifically for debugging AI, it's nice when they can pop up little texts about what they're doing. It's like, oh, I'm walking now, or I'm eating now, gosh, I'm hungry. And then you can kind of see what they're thinking. Anyway, I'm going to end it here. The next behaviors would take at least another 15 minutes, and it's already 10:20. And you guys don't realize this, but I go back and I watch this again so that I can put those chapter markers in. And even though I watch it at double speed, which is quite funny, by the way, it takes a long time, and I would really rather be using that time to develop. So, all right, I don't think there's anything else to go over today. What I want to get done for a next release is I want to have the Gaefen, like with some minimal behavior, even if it's just walking around and joining the group and going home, you're walking back to their home, so that you guys could spawn your own Gaefen and play with them a little bit. I want to finalize the fractal enough that I'm willing to let other people look at it. I want to finalize, if I can, fit dungeon generation in enough to play with it. But there's like a ton of other things that I need to wrap up before release. I'm trying to cut a release like on Monday or Tuesday. It may have to wait till the next weekend, depending on how much I get done. Also, day job work is in flux right now because our 6 or 7 year project has kind of ended, and it's not clear what I'm going to be working on next yet. So, at any rate, I got a ton of stuff to fix for the fractal, some AI stuff to finish, and if there's time, integrating simple dungeon generation, so we might be able to go find some tunnel and wander around inside of it. And I think there was something else that I thought of while I was doing the AI stuff that's critical as well. At any rate, a lot of list of stuff to do, and staying on this live stream is not helping me do it. So thanks you guys for joining. If there are any questions, I'll give it a beat for any final questions. Otherwise, I'm going to go ahead and start doing the normal thank you stuff. So please like, comment, and subscribe. Tell your friends if they want to subscribe. Any engagement we can get, to get this in more people's point of view. I'm getting really close to wanting to release this publicly, not requiring the password to access the page and stuff. And it'd be nice if word of mouth had gotten some swell before then. All right, guys. Thanks for joining. I will see you next time, and you guys work on some cool stuff on your own, okay? Thanks. And I look forward to doing more of this in the new year. All right.